In today's video, we'll be taking a look at the Zetec MIS-21C eddy current test instrument and some of the peripherals that you can use to inspect conductive materials with this tester. So first of all, we have just a conventional aluminum EDM notch block. It's got 3 shallow surface breaking notches in. Of course, you want to use a small pencil probe if you want to find small cracks. So that's not too exciting, but a very necessary part of eddy current testing. Then next, we're going to be looking at the Zetec ZM5 rotary scanner for inspecting fastener holes with the fastener removed. The one thing I want to say about the rotating scanners is when you insert the probe, there's pins in the probe, 4 pins, and there's a red dot on the probe. There's also a red dot on the scanner. You want to make sure that you line up the 2 red dots, and then just simply push the probe in. And when you line up the red dots, it does 2 things. It keeps from bending the pins, and then the second thing it does is it allows the scanner and the software in the test instrument to know the precise rotational position of the probe at any given moment in time. So that becomes useful when you're doing things with the C-scan, like measuring flaws or changing the reference point of the C-scan, things like that. They also included in this kit some other type of rotating probe. I don't know what it is, but I'll find out when I hook it up to the MIS-21C and see what the flaws look like. Sometimes you got to do a little trial and error to figure the probes out. I did talk about this rotating scanner hole test block. This has 3 layers in it, and these holes are 3/8 of an inch. And it says Zetec on the top. You know, the company's been around over 50 years. Each one of these holes has a series of circumferential and axial notches of varying depths. So it'll be interesting to see how our MIS-21C tackles that test. Next, I have a surface weld probe. I'm not sure if these are arrays in here. They probably are. But because it's flexible, you can follow the contour of a weld bead. So we'll be inspecting some welds with that. Next thing we have is a sliding probe in the toolbox. Sliding probes are reflection, or in other words, driver pickup. And sliding probes have arrows on them. The paint on this one's wore off, but they're usually a green arrow and a red arrow. You got to scan in the direction of the green arrow. Sliding probes have wider coils. Wider coils are used to penetrate deeper in test material. So this particular aircraft panel reference standard has a couple different layers of flush mounted rivets. So you would take a sliding probe, and once you calibrate it, just slide it along the surface, and you'll be able to find surface and subsurface cracks. So when you do this multi-layer stuff, you have to use multi-frequency to inspect the different layers with the best amount of eddy currents per layer. Next, we have surface array. So this is an array coil. You don't call it array coil, call it an array ribbon maybe. But each one of these apparatus has many, many coils in it, all spaced in such a way where you have 100% overlap. And they operate in the send-receive configuration. But basically what you do is, this is the sets of the coils, and what that does is it just connects into this, I don't know what you don't call it, a probe delivery vehicle. And this is actually the encoder. So here's how it works. This is your connector to the instrument. You're just going to snap your array ribbon into it, and then you'll snap that onto the probe delivery system. I'm not sure which way is right side up. I haven't used one of these things in a while. So now what this does is it's got the arrow on it, so that's the direction that you're going to scan. You know what? I got it on backwards. It's like this. Yeah, because you want to have it closer there. So when you're scanning, the wheel turns, and that axial encoder inputs distance, location, information into the test instrument. So that comes useful when you're referencing flaws, calculating distance. It also helps in the determination of digitization rate, probably. So let's see, we're gonna be using that. They included a couple other smaller ribbon probes. We're gonna be using those to inspect some materials. We have this thin aluminum plate has a groove that runs the whole way across. We're gonna be using that groove to verify the functionality of the array probe and the configuration in the test instrument. Well, this also has some very tiny EDM notches in here, and flat bottom holes. There's even, in the middle right here, a 0.052 inch hole used. Similar size hole used in tubing for the ASME code requirement. And then we have this thin aluminum plate that has some simulated corrosion machined into the back. So I'll probably be using the sliding probe on this as well. And that's about it. So I got the MIS-21C, I got a bunch of probes, I got the array, I got a bunch of reference blocks. So stay tuned, and we're gonna be checking out the functionality of the MIS-21C by Z-Tech.